Continuing on with our first lesson, we've already covered what a ratio is and how to write it in 3 different ways. We've also looked at a few other rules and whatnot that you need to understand. But today, with this lesson, we're going to take a look at rates. And after this lesson, you should be able to tell me what a rate is. And you also need to be able to figure out what the rate is when I give you information in a variety of different ways. So let's get right to it. What is a rate? It's nothing more than a ratio, see we know what a ratio is, of two quantities that have different units. And I told you on the previous lesson that once we started putting units to it, you'd actually understand what we're talking about when a ratio is a comparison of these two different numbers. And that's going to give us a lot of vital information there. So let's take a look at two different rates. See this? It's a, it is definitely a ratio. We have two different numbers, and they're using division there, right? 250 divided by 4. Or basically for every 250 parts, there's 4 parts of this, and they have different units. This 250 is pounds, and this 4 is feet. So it's 250 pounds for every 4 feet. Okay, so that's a rate. It doesn't really help me out there. Hmm. Just be patient. What about this one over here? 20 miles to 15 minutes. They have different units. It's a ratio, but they have different units, and that makes it a rate. Hang on a second. Are you saying that every time this person goes 20 miles, 15 minutes goes by? Yeah, that's exactly what we're saying. So there's this relationship between how far they go and how long it takes to go that distance. Yeah, that's exactly what it is. See, it's that relationship. These different units kind of ties us in a little bit closer to it. And once we actually figure out what a unit rate is, which is on the next lesson, it'll be a lot easier, actually, to get some information. So they're still ratios, but they have different units. Now, again, these rates are very useful in understanding how they interact with each other. So you might come across a question like, well, how far did this person go in, say, 1 minute? Well, if you understand that it took them 15 minutes to go 20 miles, then suddenly you go, oh, wait. I think I can do something with that information. And once I teach you how to use the unit rate, um, it gets a lot easier. Now, if I actually hide that information, you got to go figure out what the rate is first. Then you can use that information to go from there. But you've got to understand the basics, and that's why we're stuck here for right now. So it's a very useful tool, and it's not something that's always going to be come out and be called a rate. Sometimes they'll call it an average speed. Other times they'll just say, oh, how much is it the cost for one chocolate muffin? And they told you what the cost was for 10 of them. It's going to be a lot of deductive reasoning to get through this. A little bit of common sense, but sometimes it'll seem very odd. So let's just keep on making our way through this lesson here, okay? Just know that you're going to have to use that rate to help you understand the relationship between two different numbers and units. Sometimes they're actually going to give you the rate. So for example, let's just say in a problem it said John's rate was 30 miles per minute. Well, you could actually rewrite this right here. Let me get a red pen here. That was the problem's way of saying, you know what? You could have written it 30 miles 1 minute. Because see this two different units here? Well, where'd you see the one at? Well, it's 30 miles per minute. How many minutes were they talking about? They were talking about 1 minute. So as a result, you could just stack it up there and make it as a fraction. Or, remember, there's two other ways you could write the ratio, and that's all that a rate is. Just make sure that you tag the miles with the first number and the minutes, the second unit, with your second number, or the one that's on the bottom of your fraction. That's pretty important. What is another way that we could do this? Other times you're going to have to be given like an informational passage or a story problem, and you're going to have to kind of pick out this information yourself. And they won't even say what is the rate. Sometimes they will, sometimes they won't. And you'll just kind of have to go, well, let me take a look here. Mary calculated the school fundraiser for a marathon would raise $28 every 3 miles the students ran. Now, in your brain, aren't you literally just saying, well, let's see, there was $28 for every 3 miles. Oh, couldn't I just do that? What's the rate? $28 over 3 miles. Yeah, that's the rate. Because for every 3 miles that the kids complete in that race, they've raised $28. Why am I putting $28 on top? Uh, No particular reason, but $28 came first, so I stuck it there on top. I just put dollars here to let you know what the units are. You can just leave the dollar sign there and cross this off if you want to. People understand. But then the other situation is I put 3 miles on the bottom because it did come second. Is there anything wrong with this? Um, Not really. I would just say if they're asking for a rate in a particular order, if you remember from our first lesson where it was like blue cars and red cars, and they said they wanted the blue cars to be listed first, so we had to do that. Make sure that you read that question very carefully and follow the clues to give them exactly what they want. Sometimes they'll tell you exactly how to do it. You just have to read. Um, but then there's other situations that we come across. You have to deal with these table charts and that sort of thing, and people really don't fare with these very well, and I don't understand why. So let's take that same problem that we just read with the school marathon, and let's put it in the table, and let's just show it to you like this. The table below showed how much money the school could raise in the marathon fundraiser. So here's the table. Pulling this down a little bit more. There we go. The distance that the kids ran was 3 miles, 6 miles, 9 miles, 12 miles. And remember, it said could raise. So if they ran 12 miles, how much money could they get? Oh, $112. If they ran 6 miles, how much money could they get? Oh, $56. And oh, look at this. If they went 3 miles, they could get $28. Isn't that what we were looking at here? Yeah, it was. It was. So, if I said find the rate, here's what we would do. Find the change. Use it to make the rate in terms of money. Or, oops, sorry, wrong one. Here's what we do right here. If you really have no clue, and they're just saying find the rate, find your smallest part in the table and just make a ratio. And then stick these labels with its numbers right here, because these are the different units. So I used money last time, so let's just go ahead and put that on top. Okay. So they can make $28 for how many miles? 3 miles. And just to remind you, it's a different unit on top. It is dollars. So I'll put that in parentheses. And there you go. Here's our rate. Now, I did want to take just a moment to point this out. Imagine if we'd used, well, let's just use this one right here. If we'd used this one, we'd said $56 over 6 miles. Ask yourself this, is this a simplified ratio? No, it's not a simplified ratio. I could divide both of them by 2, and that would make it 28 over 3, and oh look, that's the same thing. And it's going to work out the same way over here in this chart. It doesn't happen that way all the time, but for today's lesson, it's certainly going to be that way each time. So it doesn't really matter which one that you choose, but if you choose these bigger numbers, you're still going to have to simplify it back to the smaller one. And sometimes the smallest ones that you see from the table, you'll still be able to simplify. For example, if this had been a 4, and this had been a 4 over here, it would have been $7 for 1 mile. It just didn't work out that way. All right, here's the very last one. Find the change. Use it to make the rate in terms of money earned to cupcakes sold. I don't like how I said find the change here. I'm trying to lead you about what I want you to do with this problem. Basically, it's this. I can't just use, this is like a vertical table here. I can't just use 0, 0 as a rate and 1050 over 3 and 3150 over 9. I can't really do that. What I can do though is I can figure out, well, what was the difference between 0 to 3? Well, that went up by 3. See that? And what's the difference between 0 to 1050? Well, that went up, so I'll put a plus sign there at 1050. That's interesting. And then this went from 3 to 9, so let's move that up there. How much did that increase by? 3 to 6. How much did I have to add on to that? 6. And how much did I have to boost this up by? My goodness, is that really 21? Yes, it is. Um, so that's odd. That's interesting. Whatever you want to look at it. But now what you can do is you can come back and you can use these changes to build your ratio. You can use this 3 because it changed from the 0 to the 3 by 3, and you can use this 1050 because it went from 0 to 1050 to build your ratio. It's my personal preference you just use this one over here first. So it's money. This is going to be our first number, and the left side will be your second number. And 3 was the number of cupcakes sold. So we'll say $10.50 for 3 cupcakes. There's our rate. So basically, it gets $10.50 for every 3 cupcakes the person sells. It doesn't really matter if you're sure that it is a same ratio all the way through in this table, and you're never quite for sure, so it's best to do this. Go through and check the whole table out and make a bunch of different rates and see if it simplifies down to the same thing. So this would be $21. So that's dollars on top. That's the one on the right side. And we'll put 6 cupcakes on the bottom. Now, can we make 21/6 into 1050 over 3? Yeah. If you divide this by 2 and divide that by 2, it would be the same thing. So we're kind of like, well, sweet, that's the same thing. And as a result, it means that you could use either one of these rates. If it doesn't simplify down to the smaller one, then there's something weird there, and it's not going to be really dealing with ratios and rates and proportions. And we could show you later, and we will in the next lesson, about how to make this one even easier. But it's time to really just get you some practice learning how to find these rates.